x squared minus 4 squared. All the way across on positive, because anything squared is always positive. So when I divide these two, a positive divided by a positive is still positive. A negative divided by positive is still negative. So for the intervals of increase, what are the intervals of increase?
Negative infinity
It is not negative infinity to 0.
to 2.
Negative 2.
Negative infinity to negative 2. Union negative 2. Negative 2, 0. Why can I not go from negative infinity to 0? Because 2 is not part of the function. I can't be increasing when my function is not defined. Okay? Always break it up into those little intervals that you have. Don't ever just say, oh, positive, positive, let's skip through the number. Always break it up.
But even if it's an inflection point, is it still increasing? It's only because those are, it's only.
I know those are inflection.
No. He was saying if pretend negative 2 was an inflection, which it could be. Okay? You don't, at that exact moment, it's neither increasing nor decreasing, it's holding steady at that
So you
moment.
have to look like this.
So you don't have to include it. There's what you'll learn as you move on in math if you end up doing more. I think it's beyond Calc 3 if you take like a real analysis course. There's strictly increasing and just increasing. Increasing means you could be increasing or holding steady. Strictly increasing means you're for sure increasing over point. So I'm not going to be picky about that. Okay? But because my function's not defined at negative 2, you can't be increasing there.
But if it were defined.
Then I don't care. Then I wouldn't really care. But just to be safe, you might as well split it up.
He said we don't have to read.
It doesn't matter. All the teachers, we've got a general consensus that if the function's defined, then we won't care. But to be safe, you might as well break it up, just as you see it. All right, that's my intervals of increase. What about my intervals of decrease?
2 to 0 to
0 to 2, union
2 to infinity.
2 to infinity. Okay. Then it asks for my local maximum. All right. Well, do I have a local maximum?
No, you can't. Because infinity is.
I do have a local maximum.
0.
0, right? When I change from increasing to decreasing, that's where you have a maximum. As you're going through and doing these problems, I highly recommend you do some hand or body graphing as you're going through these, and that'll kind of help you to see it. Okay? If you're increasing and decreasing, you had to have had a maximum point there. Does that make sense? So this is going to be my local max. So how do I find the actual point? I need to plug it in. So I need to know what is f of 0. So f of 0 is going to be 1 over 0 squared minus 4, which is negative 1/4. So my local max is at 0, negative 1/4. What about a local min? How do you know when you have a min? When I'm decreasing to increasing, negative to positive. Do I have any of those places? No. So I have none. All right, so then the next thing they want to know is intervals of concave up and interval of concave down.
Secondary.
To figure that out, I use my second derivative. So lucky for us, they computed the second derivative, so we don't have to go through and do the computation. So using the second derivative, where are these possible inflection points? Well, they happen when the second derivative is either 0 or undefined. So what would make it 0? 2 doesn't make it 0. Nothing makes it 0. What would make it undefined?
2 and negative 0, right?
2 makes the denominator 0, but if the denominator is 0, then it's undefined. Does that make sense? So the only possible inflection points happen at negative 2 and 2. But are those going to be inflection points?
No.
No, why? Because we already decided that they were asymptotes. Alright, so here's what we'll do. To figure out those intervals of concavity, I'll make another number line, have double prime, plug in negative 2 and 2. I've got 6x squared plus 8 and x squared minus 4 to the third power. 6x squared plus 8. Read across. Tell me what the sign is going to be. Positives or negatives? Positive. 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 Great. What about the denominator?
Negative.
How about positive? Negative. division, I go from the positive and negative to the positive. So where am I concave up? Negative 2 and negative 2 union
And 2
to infinity, and I'm concave down, negative 2 to 2. Do I have any inflection points? I have none. All right. If I were to have an inflection point, how would you find it?
You just,
Where it changes concavity. Exactly. So negative 2 kind of looks like an inflection point, but I know it's not one because it was an asymptote. Does that make sense? All right. So I've got all the information I want. Then if they want us to sketch the graph, let's go ahead and do that. So to sketch the graph, start with your asymptotes. I've got a vertical asymptote at 2 and at negative 2. Got a horizontal asymptote at 0. I've got a y-intercept at negative 1/4. I know I'm going to be decreasing from 0 to 2, or from negative 2 to 0 and 0 to 2. So I'm decreasing and following the asymptotes. It obviously has to look like that. The rest of it I have to be increasing. So between negative infinity and negative 2, I'm increasing, but I'm also concave up. So increasing and concave up has to look like this. And then for the other side, I have to be concave up, but decreasing. So it should look like that. And that would be what your graph.
Will we have to draw pictures on
You may. Now, in terms, I don't know that you're going to get a problem this long on your final. You may. Like I said, I haven't seen it, so I can't really tell you for sure. They may just give you the information and not have you figure it out yourself. There was a problem like that on your, whatever, test 2 maybe? Right, when I gave you the limit is equal to this, here's a number line for the derivatives, sketch a picture of the graph. You may have something like that that you have to do. Okay. So,
Is our final in this room? Or is it
no, it's in another room. Everything is posted on my gateway.
is it,
Alright.
and then 300 points or something chances someone being 300?
300 points. It's
Okay.
like,
Double check.
it's a little, it's just
Two
about 2
tests.
tests.
Can you do some number 2 on the in-class review? I just can't think.
Number 2. Sketch roughly the graph of that function and find the points of discontinuity. So if I'm sketching the function, f of x equals 1 plus x squared, whenever x less than or equal to 0, 2 minus x, whenever x is in between 0 and 2, and x minus 2 quantity squared, whenever x is greater than 2. Okay, so let's start off with the top part. 1 plus x squared, what does that look like?
It's a problem.
A parabola which has been shifted up 1. Okay, so looks like this. And it would look like this over here, but I know that I'm only interested when x is less than or equal to 0. So only for those x values. Then what does 2 minus x look like? A line that has a y-intercept at 2, and it has a slope of negative 1, down 1 over 1, down 1 over 1,
From 0 to 2?
from 0 to 2, but I don't include the value at 0. I do include this value over 2 though, that's a constant circle. Then x minus 2 squared, whenever x is greater than 2, what does that look like? A parabola which has been shifted to the right. So its vertex is actually right here. So it looks like this and like this, but I'm not interested in the less than 2 part, only in the greater than 2 part. All right, so that's what the graph looks like. So where am I discontinuous? Discontinuous at x equals 0. Am I discontinuous at 2?
Yeah, is it a vector thing?
I'm not asking you, am I differentiable? I'm just asking
Oh.
continuous. I'm continuous at 2. Why? What do you need to be continuous at